All right, so today we're diving deep into Volte optimization.
Yeah.
We've got this technical document here,
Mm-hmm.
and it's all about making those voice calls over LTE
Right.
really, really shine.
It's a fascinating topic.
It is.
Most people don't really think about
Yeah.
what goes on behind the scenes
Yeah.
when they make a call.
They just expect it to work,
Exactly.
but there's so much going on
Uh,
under the hood.
So we're going to try to demystify that a little bit today.
Yeah, and this document is like our guide
Yes.
to understanding how to make these networks work flawlessly.
What's really cool is that we're going to
Yeah.
learn about those key performance indicators.
Right, the KPIs.
The KPIs, exactly.
And then,
the things that engineers are always looking at.
yes, and then how to actually
Right.
troubleshoot these networks
Yeah.
when those KPIs start throwing up red flags.
Exactly like being a Volte detective.
I love it.
Right.
Volte detective.
We're going to put on our detective hats.
Okay, so let's start with the basics.
All right.
What is Volte?
So Volte stands for Voice over LTE.
Okay,
And it's basically how we make calls
right.
on those super fast 4G networks.
That we've all come to rely on.
Exactly.
And 5G is out there, but
Yeah, 5G is emerging.
but 4G is still the dominant
It's still very prevalent.
technology for a lot of people.
Absolutely.
Okay, so Volte relies on a bunch of features
Yes, does.
working together.
It's a whole ecosystem.
Okay,
And this document mentions things like
okay,
multiple radio bearers per user,
okay.
which essentially means your phone can handle different streams of data
Oh, wow.
all at the same time.
So, like,
Yeah.
it could be handling my voice call
Uh-huh.
and, like, downloading something at the same time?
Yes, exactly.
Interesting.
And it also talks about this thing called a QoS-aware scheduler.
QS.
QoS.
Uh-huh. What is that?
So QoS stands for quality of service.
Okay.
And it's basically a mechanism that makes sure that your voice data
Okay.
gets priority
So it's like
on the network.
VIP treatment for the voice.
Yes,
Yeah.
exactly.
Interesting. Okay.
So even if you're doing other things on your phone like browsing the web or downloading files,
Right.
the QoS-aware scheduler
Uh-huh.
will make sure that your voice call
Stays nice and clear.
stays clear and doesn't get interrupted.
Oh, that's so interesting.
Yeah.
So it's all about making sure
It's about prioritization.
that your voice call is the VIP
Exactly.
of all the data that your phone is handling.
Absolutely.
That's fascinating.
It's really cool how that all works together
It is.
to give us a seamless experience.
Yeah, we just take it for granted.
We do. We just pick up our phones
Data call,
and expect it to work.
expect it to work, but there's a lot.
But there's magic happening behind the scenes.
There is magic.
There is.
All right, so we've got this complex system,
Yes.
right?
Yeah.
But as with anything complex, things can go wrong.
Of course things can go wrong.
So that's where this whole idea of optimization comes in,
Exactly. Optimization is key to
Right.
making sure
to making sure the network is
that the network is running smoothly
running smoothly
and efficiently,
and that calls are,
Yes.
going through without a hitch.
and that the calls are high quality.
High quality.
Yes.
Okay, so how do we know if things are running smoothly?
Right.
How do we know if things are optimized?
That's where those KPIs come in.
The KPIs.
Yeah.
Tell me about KPIs.
Okay, so KPIs stand for key performance indicators.
All right.
And they're basically like the vital signs of a Volte network.
Oh, okay.
So they give us a snapshot
Okay.
how the network is performing.
Okay, so like a doctor would check your pulse and your...
Exactly. Exactly like a doctor would check a patient's vital signs.
Right.
We're checking the vital signs of the network.
Got it. Okay.
And one of the most important KPIs is accessibility.
Accessibility. Okay.
And this basically measures how often calls actually get connected successfully.
So like if I dial a number,
Yes.
does it actually ring on the other end?
Exactly. Does it actually go through?
Okay.
And do you actually get to talk to the person?
Right, because I've definitely had those times where
Well, we've all been there.
like call failed or network busy.
Exactly. Network busy.
Yeah.
That's a sign of poor accessibility.
So if the accessibility KPI is low,
Yes.
that means people are having trouble
People are having trouble making calls.
making calls.
And that's a problem.
That's a big problem.
Yes.
Okay, what other KPIs should we be paying attention to?
Another really important one is drop call rate.
Drop call rate. Okay.
So this tells us how often calls are dropped unexpectedly
Once they've already been connected.
once they've already been connected.
So you're in the middle of a conversation.
Yes, you're chatting away,
And all of a sudden,
and suddenly
the call just ends.
the call drops.
Yeah, the worst.
It's the worst.
Especially if it's an important call.
Especially if you're in the middle of something important.
Right. Or like giving someone directions.
So we're trying to close a deal.
Oh, yeah, or like an emergency situation.
Exactly.
Oh, that would be terrible.
Yeah, so drop call rate is a really important KPI
Okay, so that's a big one.
because it tells us about the reliability of the network.
Reliability. Okay.
Yeah.
So if the drop call rate is high,
Yes.
that means there are problems with the network.
It could mean there are problems with coverage,
Coverage.
with interference, or even with the equipment itself.
The physical, like,
Physical infrastructure.
tours and all that.
Exactly, the cell towers.
Interesting.
All of that can contribute to a high drop call rate.
Okay, so we've got accessibility.
Yes.
We've got drop call rate.
Huh?
What about the quality of the call itself?
Right, because you can have a call that connects
Yeah,
and stays connected,
right.
but the quality is terrible.
Yeah, like you're talking...
The other person sounds like a robot.
Yeah.
Exactly, or like they're underwater.
I've had those calls too.
We've all been there.
So is there a KPI for that?
There's a KPI called VoIP integrity.
VoIP integrity. Okay.
And this one measures the quality
Okay.
of the voice packets
1 second.
that are traveling over the network.
Okay.
So it's basically looking at how much of the voice data is getting through intact
Okay.
and how much of it is getting lost or corrupted along the way.
So, like, are those little packets,
Yes.
are they getting lost or are they just arriving?
They could be getting lost.
Okay.
They could be getting corrupted.
Good ball. Okay.
They could be arriving out of order.
It's out of order. Okay.
All of that can affect
Interesting.
the quality of the call.
Okay. So a low VoIP integrity score means...
So low VoIP integrity score means that you're probably going to experience
Yeah.
things like
Like, what?
choppy audio,
Choppy audio. Okay.
robotic voices,
Yeah.
delays,
Delays.
echoes,
Okay. So all sorts of things.
all the things that make a call unpleasant.
Unpleasant.
Yeah.
I've had those calls where it feels like I'm talking to myself.
It's very disorienting.
Very disorienting, yeah. So VoIP integrity
VoIP integrity is key.
is an important one.
Yes.
Okay, so these KPIs...
These KPIs give us a really good picture
Yeah.
of the overall health of the network.
So they're like our
They're like our dashboard.
dashboard.
Yes.
Okay.
And they tell us at a glance
Okay.
whether things are running smoothly.
Okay. But what happens when those numbers start looking bad?
That's when we have to put on our detective hat
Okay, here we go.
and start troubleshooting.
Okay, so we're Volte detectives now.
We are Volte detectives.
So let's say we're looking at our dashboard
Yes.
and we see some alarming KPIs.
Uh-huh.
What do we do?
This document actually gives us a really structured way
Okay.
to approach the problem.
Okay, good, because I need structure.
We all need structure.
Okay.
So we can start by looking at
Yeah.
what are called accessibility problems,
Accessibility problems.
which are those cases where
Mm-hmm.
you can't even make a call in the first place.
So the call doesn't even go
It
through.
doesn't even go through.
Like you're getting a
You're getting a network busy message.
network busy or call failed.
A call failed, yeah.
And you're just like, what's going on?
Right. Is it me? Is it the network?
We've all been there.
I know. I always restart my phone
Oh, yeah. That's the first thing we do.
every time.
Turn it off and turn it back on again.
Yeah, see if that fixes it.
Hopefully it fixes it.
Sometimes it does.
Sometimes it does.
Sometimes it doesn't.
Sometimes it's more complicated.
Okay, so accessibility problems.
Accessibility problems.
What are some of the usual suspects?
One of the usual suspects is something called RRC failures.
RRC failures.
RRC failures.
Okay, what does that even mean?
So RRC stands for radio resource control.
Okay.
And basically an RRC failure means
Okay.
that your phone is having trouble establishing a connection
So it's like,
with the cell tower. It can't even get a signal.
can't even get a signal.
Okay.
Or it's having trouble maintaining that signal.
Okay.
So it's like the very first step
Okay.
in making a call.
Right.
Your phone needs to establish that connection
With the tower.
with the tower.
Okay. So what could cause an RRC failure?
Oh, there's a bunch of things.
Okay. Like what?
It could be something as simple as the
Yeah.
tower being overloaded.
The tower's overloaded. Like
Yeah.
too many people are trying to use it
Too many people are trying to use it at once.
at the same time.
Like a traffic jam.
Like a cellular traffic jam?
A cellular traffic jam, exactly.
Okay. What else?
Or there could be interference
Interference
of other signals.
from other signals.
So like Wi-Fi signals
Uh-huh.
or other cell towers
Other cell towers.
or even things like microwaves.
Microwaves can interfere
Microwaves can interfere.
with cell signal.
Yes.
Wow. I did not know that.
Yeah. It's surprising, but it's true.
Okay. So interference from other things.
Right.
What else?
Or the signal could just be too weak
Too weak.
in that area.
So like
Like if you're in a rural area
in a rural area or like a basement or something.
or basement, yeah.
Right.
Or you're inside a building with thick walls,
Right.
the signal might not be able to penetrate.
Interesting.
So you might have a weak signal.
Okay.
and that can cause an RRC failure.
Okay, so weak signal.
Uh-huh.
Anything else?
Yeah, there could even be something wrong with the equipment.
With the equipment on the tower itself.
On the tower itself, like a faulty antenna
A faulty antenna.
or a problem with the radio unit.
Okay, so there's the physical equipment.
The physical equipment can also cause problems.
So it could be a lot of different things.
Could be a lot of different things
that cause that RRC failure.
that contribute to RRC failures.
Okay, and that's just one type
That's just one type.
of accessibility problem.
Accessibility problem.
Okay, what other accessibility problems might we encounter?
Another one that this document talks about is S1 failures.
S1 failures.
S1 failures.
Okay, those sound even more mysterious.
They do sound a little more technical.
Yeah.
But basically an S1 failure means
Yeah.
that the communication between the cell tower,
Okay.
which is also known as the E-node B,
The node B. Oh, okay.
and the core network.
Okay, the core network.
The core network breaks down.
Okay, so the core network is like
The core network is like the brain
the brain,
of the whole operation.
whole cellular operation.
Exactly.
Okay.
It's where all the intelligence resides.
Okay, so the tower is trying to send a message
Yes.
to the core network,
Right.
but it's not getting through.
And it's not getting through.
That's the S1 failure.
That's an S1 failure.
Okay, and what could cause that?
So again, there are a few things that can cause this.
Okay.
One possibility is that the MME,
The MME.
the MME,
Yeah.
which is a key part of the core network,
Okay.
is overloaded.
The MME is overloaded.
Yes.
What does MME stand for?
It stands for Mobility Management Entity.
Mobility Management Entity.
Yeah.
Okay, and it's overloaded, so it's like,
It's like the control center
yeah,
getting flooded with requests,
with too many requests.
with too many requests and not being able to keep up.
Okay, so it's like a cellular traffic jam.
Exactly. It's another cellular traffic jam.
Okay, so the MME is overloaded.
Uh-huh.
What else can cause these S1 failures?
Well, it could also be a problem with the physical connections
Yeah, okay, the physical connections
between the tower
between the tower
and the core network.
and the core network. Okay.
So think like fiber optic cables
Fiber optic cable.
getting cut
Oh, wow.
or routers malfunctioning.
Routers malfunctioning. Okay.
So any problem with those physical connections
Yeah,
can disrupt that communication
and cause an S1 failure.
and cause an S1 failure.
Wow, okay.
And believe it or not, it could even be a single problematic phone
Wait, well,
causing the disruption.
one phone
One phone
can mess up
can potentially mess up
the whole signaling process.
the whole signaling process.
How is that even possible?
It's rare,
Okay.
but it can happen.
Wow.
Some phones might have software glitches
Software glitches, okay.
or compatibility issues
Compatibility issue.
that interfere with the way the signaling works.
Interesting. So it's like one bad apple
It's like one bad apple,
spoiling the whole bunch.
boiling the whole bunch.
So that's a possibility.
It's a possibility.
Wow, it's amazing to think that
It is.
one little device
One little device
can have such a big impact
can have such a huge
on
impact
the whole network.
on the whole network.
Wow. Okay, so we've got RRC failures.
Yes.
We've got S1 failures.
Mm-hmm.
And those are just two types
Those are just two examples
of accessibility problems.
of accessibility problem.
And there's actually a whole other category
There is
called E-era failures
E-era failures.
that we need to explore.
We do. So we were talking about all those things that can go wrong
Right.
when you're trying to make a Volte call.
Okay.
Right. All those accessibility problems.
Yeah, and we covered those RRC and S1 failures.
Right.
And now we're about to dive into ERA failures,
Exactly.
which, if I remember correctly, have to do with actually setting up the pathway
Yes.
for the voice data to travel
Right.
once the call is connected.
You got it.
So it's like you've dialed the number,
Right.
the network knows who you're trying to reach,
Yeah.
but now it needs to build like a secure tunnel
A secure and reliable tunnel.
for your voice to travel through.
Yeah.
If that tunnel doesn't get built,
Right.
that's where we run into these ERA failures.
That's where the call fails.
right, which means
No conversation.
no conversation.
You can't talk to the person you're trying to reach.
Ugh, so frustrating.
Very frustrating.
Okay, so what are some of the common culprits?
All right, so this document highlights a few.
Okay.
One is something called GBR overload.
GBR overload.
GBR overload.
And what does GBR stand for?
GBR stands for Guaranteed Bit Rate,
Guaranteed bit rate. Okay.
and it's basically a way for the network
Yeah.
to reserve a certain amount of bandwidth
Oh, okay.
just for your voice call.
So it's like a VIP lane
Exactly a VIP lane.
for my voice data.
For your voice data to make sure that it gets through.
So it's not competing with all the other data.
Exactly. It has its own dedicated lane,
Wow. Okay.
so it doesn't get stuck in traffic.
Okay.
But if there's not enough of that special bandwidth available,
Yeah.
the call can't go through.
Oh, so it's like trying to merge onto the highway
Exactly like trying to merge onto a highway
during rush hour?
during rush hour,
Yeah.
and there's just no space.
Yeah, you're just stuck.
You're stuck.
So this can happen if the network isn't set up properly.
Right, if the network is not provisioned correctly,
Uh,
with enough resources allocated for GBR traffic.
So the engineers need to like adjust those settings.
Exactly. They need to make sure that there's enough bandwidth reserved.
Okay, so it's like widening the highway?
Yes, widening the bandwidth highway.
Okay, what else can cause these ERAB failures?
All right, so another thing that can cause problems is security issues,
Security issues, okay.
because Volte calls are encrypted.
Right, for privacy.
For privacy, exactly.
Okay,
So if there's a problem with the encryption,
yeah,
the call can't be established.
it just won't go through.
It won't go through.
Okay.
It could be something like mismatched security settings
Mismatched security settings.
between your phone and the network,
Okay.
or issues with the encryption keys themselves.
Oh, wow. So it's like
It's like trying to open a lock
with the wrong key.
with the wrong key. It's not going to work.
It's not going to work.
Right.
Okay, so security issues
Yeah.
make sense. We definitely don't want anyone eavesdropping
We definitely don't want that.
on our conversation.
Oh.
Okay, anything else that can trip things up at this stage?
Yeah, sometimes good old-fashioned transport issues are to blame.
Transport issues, okay.
Remember those fiber optic cables and routers we talked about earlier?
Right, the physical infrastructure?
The physical connections.
Yeah,
Well, if there are problems with those physical connections,
okay.
it can disrupt the whole process of setting up that ERAB pathway.
So it's like if there's a broken cable somewhere.
Exactly. If there's a broken cable or a faulty router,
Yeah.
that can cause problems.
Okay, so we've got GBR overload,
Yes.
we've got security issues,
Uh-huh.
and we've got transport issues
Right.
as the main suspects for ERB failures.
Those are the big ones.
Okay, so how do engineers actually figure out
That's a great question.
which one is causing the problem?
So they use these special counters.
Counters.
They give them a peek into what's going on
Okay,
at the network level.
so they can see like
Right. They can see things like
where the failure is happening.
exactly where the failure is happening.
Okay,
Whether it's happening because of something at the cell tower
okay.
or somewhere else in the network.
Oh, so it's like a set of clues
It is like a set of clues.
to help them solve the mystery.
They're like network detectives. They are.
Okay, but let's say we've managed to establish a call.
Oh, so-
We've overcome those accessibility problems.
right. We've got the call connected.
We've got the call connected.
Yeah.
Now the challenge is keeping it going.
Exactly.
And that's what this document calls retainability, right?
Retainability, exactly.
So we've moved from getting the call connected
Right.
to making sure it stays connected.
Keeping it good.
Keeping it going.
Yes.
Okay.
And one of the big challenges here
Yeah.
is dealing with something called eNode B releases.
eNode B releases.
Like it means the cell tower itself
The tower itself
is dropping the call.
is dropping the call.
Yes.
Ouch.
Not good.
What would cause a tower to do that?
So lots of things can cause a tower to drop a call.
Okay. Okay, like what?
One common culprit is coverage issues.
Coverage issues. Okay.
Well, if you move out of range of a tower,
Right.
the signal gets weaker and weaker,
Yeah.
and eventually the tower might decide
Okay.
that it can't hold on to the call any longer.
So like if I'm driving through a tunnel
Exactly. If you're driving through a tunnel
or a really remote area
or a really remote area
where there's just no coverage,
where the signal is weak,
the call might drop.
the call might drop.
Okay.
But even if you have decent coverage overall,
Okay.
another issue that can cause the tower to drop the call
Mm-hmm.
is something called handover failures.
Handover failures. Okay.
So as you move around,
Yeah.
your phone has to constantly switch
Okay.
from one tower to the next
Right. To maintain a good
to
connection.
maintain a good connection.
Yeah. Okay.
And if that handoff isn't smooth,
Uh-huh.
the call might get dropped.
So it's like a relay race.
Like a relay race, exactly.
Of course, passing the baton
Passing the baton
smoothly is critical.
is critical.
Okay.
The network has to figure out which tower is the best target,
Okay.
make sure the signal is strong enough,
Right.
and transfer all the call data
Okay.
quickly and efficiently.
Sounds complicated.
It is a complex process.
What sorts of things can mess up that handover process?
So our old friend, interference.
Interference again.
Interference can definitely play a role.
Okay.
If there are strong signals from other sources,
Right.
it can make it hard for the network
Okay.
to do the handover properly.
So all those things we talked about before.
Yes.
Other cell towers, Wi-Fi networks,
All of those things.
even those rogue microwaves.
Even microwaves.
They can interfere with handovers too.
They can interfere with handovers.
Wow. Okay.
And then, of course, there are also radio link failures,
Radio link failures.
which are problems
Okay.
with the actual connection.
The connection between my phone and the tower.
Between your phone and the tower.
Okay.
And this could be because of faulty hardware.
Faulty hardware.
Environmental factors like heavy rain.
Rain.
Or even physical obstacles.
Physical obstacle.
Like buildings or trees.
So like anything that's blocking
the signal.
Blocking the signal.
Yes.
Okay, so many ways for things to go wrong.
There are a lot of potential issues.
How do engineers figure out which of these
That's the challenge.
is causing the call to drop?
It's like a puzzle.
Yeah.
They have to look at different pieces of information to try to figure out what's going on.
So they're like detectives.
They are detectives.
Looking for clues.
Looking for clues.
Okay.
They might look at counters.
Okay.
They might look at logs to try to see if there are any patterns.
Okay, so for instance, if they see a particular counter spiking,
Right.
it might point to the E node B.
Yes.
Releasing calls abnormally.
Releasing calls abnormally.
Okay, and then they need to investigate further.
Exactly.
To understand why.
To figure out why that's happening.
Okay, so we've tackled getting the call connected.
Right.
We've tackled keeping it connected as we move around.
Yes.
But there's still another piece of the puzzle, right?
There is.
We need to make sure the call actually sounds good.
Absolutely.
And that brings us to mobility problems, I think.
That brings us to quality problems.
Quality problems, okay. All right, so we're back.
Back for more.
And ready to tackle those final quality challenges.
The things that can really make or break a call.
Exactly. And I think we left off talking about
Jitter and delay.
jitter and delay.
Those are the two big ones.
Okay, give me the rundown.
All right, so jitter,
Yeah.
it's basically when those voice data packets,
Those little packets.
those packets, yeah,
Carrying my voice.
carrying your voice, exactly, arrive
They arrive at different intervals.
at different intervals.
Instead of at a nice steady pace.
So they're not actually getting lost.
They're not getting lost. They're just arriving out of order.
Arriving out of order.
Yeah.
Okay, so it's
Like
like
listening to a song
oh, okay.
where the notes are all jumbled up.
So it wouldn't sound very good.
It wouldn't sound very good.
No.
Right.
Okay, so how does that translate to a voice call?
So in a voice call, jitter can cause
Yeah.
all sorts of weird audio effects.
Right. You might hear gaps
Gaps.
or stutters in the other person's voice.
Okay.
Or it might sound robotic or distorted.
So like they're talking through a tin can?
Exactly. It can sound very metallic
Okay.
and just like packet loss.
Yeah.
Jitter can be caused by interference,
Interference again?
congestion on the network,
Okay.
or problems with the radio link
Between my phone and the tower.
between your phone and the tower.
So it's like all those same culprits
It's all connected.
that
Yeah.
we've been talking about.
Yeah.
Okay, so that's jitter.
That's jitter.
What about delay?
So delay is simply the time it takes
Okay.
for a voice packet to travel from the sender to the receiver.
So it's like the lag you get in online
Yes,
games,
it's like lag in online games.
where your actions don't register right away.
You press a button
Yeah.
and nothing happens for a second.
It's so annoying.
Very annoying.
Okay, so in Volte calls too much delay.
Too much delay can create an echo effect,
An echo effect.
which makes it hard to have a natural conversation.
Yeah, I've had those calls
We've all been there.
where it feels like I'm talking to myself.
You hear your own voice coming back to you.
It's so disorienting.
Very disorienting.
You don't know when to talk.
Right.
So engineers have to work hard
They do.
to minimize both jitter and delay.
They're constantly working on ways
Okay.
to improve the quality of VoLTE calls.
Okay, how do they do that?
So one thing they do is they optimize the network's routing algorithms,
Routing algorithms. Okay.
which basically means they're making sure
Yeah.
that the packets are taking the most efficient path
The most efficient path to their destination.
to their destination. Yes,
So it's like finding the best route on a map,
exactly. Finding the best route on a map,
avoiding traffic jams and detours.
avoiding all the obstacles. And they can also give voice packets higher priority
Higher priority.
than other types of data.
So it's like they get to go in the fast lane
They get to go in the fast lane.
on the network.
Exactly. So they don't get stuck behind all the other traffic. And they can also use something called jitter buffers.
Jitter buffers, what are those?
So a jitter buffer is basically
Hmm.
a temporary storage area for incoming packets.
Okay.
And it helps to even out any variations in their arrival time.
Oh.
Kind of smooth things out.
So it's like a shock absorber.
It's like a shock absorber for the voice stream,
I love that analogy.
right? It helps to iron out the wrinkles.
Iron out the wrinkles caused by jitter.
Exactly.
Okay, so we've covered a lot of ground here.
We have.
We've talked about all the different challenges
Yes.
involved in making sure that Volte calls
Right.
connect successfully,
Uh-huh.
stay connected as we move around,
Yes.
and sound good on both ends.
Absolutely. All the key aspects.
It's really amazing
It is.
how much complexity
Yes.
is packed into something that we use.
That we use so effortlessly every day.
I know, we just take it for granted
We do. We just pick up our phones
and make a call.
and expect it to work.
But now I have a whole new appreciation
Me too.
for all the things that have to happen
All the magic that's happening
to make that connection possible.
behind the scenes.
Yeah, this deep dive has really opened my eyes.
It's been an enlightening journey.
It has.
I hope our listeners feel the same way.
Me too.
Yeah.
So to everyone listening,
Yes.
the next time you pick up your phone to make a Volte call,
Right.
take a moment to appreciate
Yes.
all the amazing engineering,
All the hard work.
that's making that connection possible.
It truly is a marvel of modern technology.
It really is.
Yeah.
And that's a wrap
That's it for today.
for this deep dive.
Thanks for joining us.
Thanks, everyone.